Hey everyone, Mr. Voikin here, and we are moving on to the next unit, Unit 7, Relations and Functions, and we'll take a look at Lesson 1, a little bit of review and preview as it says right there. So everybody here should understand what the Cartesian coordinate system is. So if I draw this vertical line that's going up and down, we say that this is our y-axis, and going across on a horizontal line is the x-axis. Remember, at the center where the y and x-axis sort of come to a 90-degree intersection there, that is called the origin. Now, each one of these points, that would be a point. The origin is a point. They all have x and y coordinates. So as I move to the right, each one of these little lines right here is a value. So this would be 1, 2, 3, 4, 5, 6, 7. And as I move to the left, these are going to be negative values. So -1, -2, -3, -4, -5, 6, and 7. And the same thing happens on the y-axis going up and down. I've got 1, 2, 3, 4, 5, and moving down, I also have 1, 2, 3, 4, 5. So looking at the origin, if we want to know what are the coordinates are always set up with x first, then a comma, and then the y value as it sits in the Cartesian coordinate plane here. So for the origin, it happens to be 0 and 0. Now, we're going to be looking at the different quadrants. So we say that all of the, each sort of section, I've got 1, 2, 3, 4 different sections right there. And we call these quadrants. So this is quadrant 1, and it's usually the Roman numeral I. Quadrant 2, quadrant 3, and this one down here would be IV, Roman numeral for 4. So notice that in quadrant number 1, if I look at all of my x and y coordinates, they are all positive. And in quadrant 2, you can see that the x is negative and the y is positive. Quadrant 3, the x is also negative and the y is negative, and in quadrant 4, the x is positive and the y is negative. So the easiest thing to do with the Cartesian coordinate system is to plot some simple points, such as that one right there that we'll call A, this one right here that we'll call B, this one that we'll call C, and that one right there that we'll call D. So when I look at point A on there, again, we're going to be setting up our x and y coordinates. You can see that we have gone over to the right 3 units and up 4 units to get to that point. So those are my coordinates, 3 in the x, 4 in the y. For point B, if you take a look at this one, we're moving back 1 unit and up 2 units to get to that point. So we are -1 in the x and +2 in the y. On point C, you should be able to see that we're at -4 and -2, and point D is going to be at a +7 and a -1. I noticed that I did not put the negative signs in front of these numbers moving down on the y-axis. Close the bracket right there. Okay. So we've been in the past looking at the equation of a line, which is y equals mx plus b. So this is the equation of a line where m is our slope and b is the y-intercept. So if I had the equation that was y equals 3 over 2x we'll say minus 2, then when I'm looking at the Cartesian coordinate plane right here, what we're doing is we're starting off at this point. That's my y-intercept, which is -2, which is -1, -2. So that's where the line is going to go through that point right there. Now, this second one is my slope, which means the slope is going to be y over x. So the 3 is the direction we're moving in the y from that y-intercept. So you can see that we're moving up 3. So I'm going to be moving up 3 from here. There's 1, 2, and 3. And then the bottom number in this ratio right here is our x. So what is it's a positive 2, which means we're going to move to the right 1, 2 units, and that is where my point is. Now, because 3 over 2 is the same as -3 over -2, right? Negative divided by negative is a positive, and positive divided by positive is a positive. I can do the reverse, where I can go, it's going to go down 3, so 1, 2, 3 units, and left 1, 2 units. And that would be another point that falls on that line. And if I go to any one of those points right there and follow that slope, for example, 1, 2, 3 up and 1, 2 over, I get another point. And now we have a line that should go all the way through these points. And it would continue in that direction and continue down in that direction forever. Now notice here that we're talking about relations and functions, and later we're going to be focusing on the fact that we have inputs and we have outputs. Okay, so basically our input is going to be our x. So for every x value, we are only going to have one y value. That confirms that it is a relation or function. So when I look here, I basically do a vertical line test. For this value of x right there, I go straight up and straight down, and when I hit the line, does it only hit it in one spot? If so, that's good. And I want to do that basically everywhere and keep hitting that line. And if for every value of x that's put in, I only get one y, again, it is a relation or a function. And normally we're going to see this on some type of a table right here, where we're going to have x and y, and we'll start off with something like -3, -2, -1, 0, 1, 2, 3, for example, and then we will input these values right here into that x position, and that will solve for our y, which would go in this position right here. Okay, so y equals mx plus b is the equation of a line, and we have studied that in previous math courses. If we look back at our last unit, we were dealing with questions that looked like this: x squared plus 4x minus 5. Now, just like we had y equals mx plus b, we could say y equals x squared plus 4x minus 5. Now I've turned it into an equation. Now, remember from the last lesson in the last unit, we sort of said that, well, let's make this y equals 0, and we sort of laid it down on this end right here. Same thing, but I'm just saying when y equals 0, what are going to be these values right here, which is the x. Okay, well, first of all, what shape is this as well? So when I look at my Cartesian coordinate plane again, the shape that we're going to get here is going to be a parabola. Okay, and a parabola looks something like that. It goes down and back up, sort of forming this U shape. So the first thing that we have to do is sort of assume that y equals 0, and we're going to factor this one out. So I'm going to get x and x, signs are different, and the larger one is going to be a 5 and a 1. And now, remember what we're doing, we're saying x minus 1 equals 0, therefore x is going to equal 1. And I have x plus 5 equals 0, therefore x is going to equal negative 5. Okay, so what that tells me is those are when y is equal to 0, which is basically right here, that's the y 0, x is equal to 1 and negative 5. So here's the 1, and 1, 2, 3, 4, 5, that's negative 5. So the parabola is going to go through that point and through that point. And then this one right here is going to be my y-intercept. So in this case, it's negative 5. 1, 2, 3, 4, 5. So that is where it's going to go through. So my parabola is going to look something like that. And that would go up in that direction and that direction forever. Now we're going to be graphing these out on your calculator, so let's just do that really quickly. So if I go to the y equals button, and this is asking you to input a function. So we're going to input our x squared plus 4x and minus 5, and then hit the graph button, and there you see it graphs this for us. So right here at negative 5, that is one of the x-intercepts, and right here at positive 1, that is one of our x-intercepts, and down here at negative 5 is the y-intercept. So that's where that the line that's forming the parabola intersects the x and y axes. Now that we know where the points are on the x and y axes, we can also remember that how do we tell if this thing's a function? Well, for every x value, there is only going to be one y value. The x is our input and the y is our output. So you can see at each one of these, we're only getting that 1 point. Now, if I was to say, let's take a look at negative 1, 2, 3. So at negative 3 in the x, so at negative 3, what is going to be the value of y? Well, we're just going to take our original equation, which was y equals x squared plus 4x minus 5, and I'm just going to substitute. So y equals bracket, bracket squared plus 4 times bracket minus 5. And wherever those brackets are is where the x variable used to be. And I want to take that value and put it inside there. And it helps to make those brackets so that you don't get mixed up with some of your signage later on. So this just equals negative 3 squared, which is 9, and 4 times negative 3 is negative 12, and minus 5. And we can see here that y equals a negative 17 plus a 9, so it's going to be negative 8. And if I follow this line down, you can see it ends up right here. And if we were to continue over to the y-intercept right here, it basically lines up right here with the negative 8. Okay, so we'll get back into a lot of this as we're going through this unit, but it's a quick little introduction right there. So let's take a look at the first class example. Okay, so it says complete the following by writing the coordinates. This is almost too easy. Okay, so it just says take a look at point A, which is from the origin, which is right there. It's going over 2 and up 4. So it's going to be 2 in the x, 4 in the y, and make sure that you get those in the correct order. B is right here. In the X, it went -3. And in the Y, it did not move. And point C is right here, which has gone 6 over in the X and -3 down. And point D is right on the Y-intercept, so it's gone 0 in the X. And it's gone -1, 2, 3 down. And point O is right at the origin, so that would be 0, 0. Write the coordinates of a point in the second quadrant. Well, remember this is quadrant 1, 2, 3, and 4. So if I'm looking for a point in the second quadrant, that would be point E, which is going to be -2 and +3. And do the same thing in quadrant 3. That'd be point F, let's say, which is going to be -4 and -3. And complete the following table using positive or negative. I've already gone over this with you. In quadrant 1, it's positive and positive. In quadrant 2, it is negative, positive. In quadrant 3, negative, negative. And in quadrant 4, positive, negative. Okay, let's take a look at page 390. This will be class example 2. So we're looking at a linear relation. Okay, so this is going to be the equation of a line, which is y equals mx plus b. And we're asked to look at this pattern right here. So it says we've got one toothpick to start off with, which would be that one right there, and that one right there, and that one right there. So we're saying that if we look down at this table right here, we've got sort of our input right here, and this is going to be our output. Okay, so the input is the number of triangles, and the output is going to be the number of toothpicks that are formed in that number of triangles. Now notice that it's starting here with one triangle, which would start right here. So this is really 0. That's where we're starting off with. In order to create this pattern, we have to start off with 0 triangles and 1 toothpick. So really right here, this would be a 0 and a 1. Okay, so now it says basically when I have 1 triangle, I have 3 toothpicks in total right here. Now, if I look at the next one, 2 triangles, now that's where I was at. I was at 3, and notice that what we've added right here is going to be another 1, 2 triangles. So we're adding 2. To get from here to here, I added 2. To get from here to here, I also added 2. And now we have a total of 5 triangles. So following that pattern, every time we form another triangle, it looks like we add another 2 toothpicks. So that would be those 2 right there, which would finish this thing off. Oh, that last line should have been a green if we want to color coordinate this thing. Okay, and again, that was a +2. So this one right here, for 3 triangles, it's going to be a total of 7. For 4, it's going to be 9. And for 5, it's going to be 11. Now it asks you in part A, I sort of skipped down to part B right there, but it says draw the next 2. And that should be fairly simple. All you're going to do is add another triangle for the next one, and then add another triangle, and another triangle, and another triangle, and another triangle, and that could go on basically forever and ever. Now if we scroll down here, it's saying in part C, represent the data onto this grid. Okay, so notice here that I have a T, which is on my x-axis, so this one right here is my same as my x. and x is usually our input, and p is on the y, and that is going to be our output. So basically what we want to do is graph this. Now remember, when we were at 0 in the x, we started off at 1. And when we get to 1 in the x, we're going to 3, 1, 2, 3 in the y. So that would be another point right there. And when we get to point 2, as indicated right here, the y should be 5. So up 1, 2, 3, 4, 5 to that point right there. So that's going to be my next point. Now I should be able to right now take this and draw a line that goes through those points right there and continues on forever and ever. So if I follow this one right here, which happens to be x 1, 2, 3, 4, 5, it's going up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, which makes it true. Okay, so that point right there, when x was 5, then y was 11, right at that intersection point right there. Part D, explain why it does not make sense to join the points. Well, because we're trying to figure out how many triangles there are, not how many parts of triangles there are. Just like if we say, how many people does it take to do this? We can't say 2.4 people. People don't come in 0.4. So triangles come in wholes, they do not come in parts. All right, part E says, describe in words the relationship between the number of toothpicks and the number of triangles. So let's take a look at this. So if we're taking the number of toothpicks, which is 3, and the number of triangles 1, basically what we're doing is doubling the number of triangles and adding 1. Okay, so we're taking the x value, doubling it, then adding 1. So that goes back to sort of here where we're getting the 1 from. That's where we started when it equals 0. So that's where we're getting this 1 from. And now if we look at this spacing right here, I went plus 1, plus 1, plus 1, and down here it's going plus 2, plus 2, plus 2. And that's going to be the number in front of the x. And remember, we're talking about a linear equation, which is y equals mx plus b. Okay, so this number 1 right here is actually going to be that b. Okay, and the m is our slope. And remember that slope is equal to m, and m is equal to rise over run, and rise over run is equal to y over x. And if I look at it in here, the change in y over x, that's what we're looking at, the change in y over x. Well, the change in y is 2, and the change in x is 1. So that's why we're taking the number of triangles and we are doubling it and adding 1. Now this is supposed to be right down here. Same thing. And now to form the equation, well, we had it right here. Y equals mx plus b. Right? So what I want to do is grab that and put it right there and just sort of fill those in. So y equals m, which is 2x plus 1. That's the equation for the slope for this line right here. Again, 1 right here, that's the y-intercept. That's this point right here where it's crossing the y line. And this number 2 is the same as 2 over 1. And that's what's happening here. I'm going up 2 over 1, up 2 over 1, up 2 over 1, 2, 1, 2, 1. Okay, and now that I have this equation, y equals 2x plus 1, it now says use the equation to determine the number of toothpicks if there are 27 triangles. So really, this equation right here, y, I want to look back to here. What is y? Well, y is this one down here, which is p. So really, this would be better written like this. P equals 2 times t plus 1. And p, it's a little confusing here because you got toothpicks and triangles both starting with t. So you want to make sure. So toothpicks is p. So this is toothpicks, and this is triangles. So it says if I have 27 triangles, how many toothpicks will I need? So I want to say the number of toothpicks is going to equal to 2 times whatever t is plus 1. It's a really good idea to just take your variable that you're going to be substituting and put 2 brackets there. This is going to help with confusion and mixing up the signage. And then basically we're going to take this number 27 and put it into there. So I'm going to put a 27 in here and just solve for this. 2 times 27 is 54 plus 1 is 55. So we need 55 toothpicks to make 27 triangles. And the formula stays the same. And now it's saying in this one, determine the number of triangles. So that's t. So this is the one we're trying to solve for if we know p, the number of toothpicks. So now again, I'm just going to sort of substitute. I'll have like 83 is equal to 2t plus 1. Now we're just down to basic algebra. We're going to subtract 1, subtract 1. 82 equals 2t. I'll just move this up and over to here. Divide by 2, divide by 2, and we have the value of t is equal to 41. So if I have 83 toothpicks, I can make 41 triangles. Okay, class example number 3. Students in a physics classroom determine the resistance in an electrical circuit by measuring the voltage V with the current I when it was passed through the circuit. The table shows the results. Now, whenever we get a table that's written horizontally across like this, the top one is going to be X and the bottom one is going to be Y. So it's sort of always good to just label it like that. The other thing I usually try to do is sort of determine the difference between each one of these readings here. Now, if we look right here, they should be consistent. So from 6 to 18 becomes plus 12. From 18 to 36 becomes a plus 18. And from a 36 to 42 becomes a plus 6. And from 42 to 48 becomes a plus 6. Now, if we're looking at a straight line, those would have to all be the same. So I've got a couple outliers there. If I'm going to say my 6 is common, what's going on with 12 and 8? Well, let's take a look at, in order for the bottom ones to be consistent, the top have to be consistent as well. So coming from 0.5 to 1.5, that's going up by 1. This one went up by went up by a positive 1.5. This one went up by a positive 0.5. And this one also went up by a positive 0.5. So that sort of makes sense. When it went up 0.5 on the amps are 0.5 up. The voltage is up by 6. Same here and here. So these two here just made some uneven jumps, but that's still fine. That's where they took the data readings. Okay, but it's also good to go back to your 0 point. Okay, so if I wanted this one to be 0, what is it? If I want this x to equal 0, what did I have to go back? Well, I'm minusing 1 in this case, and notice, minusing 0.5. And if I'm minusing, or if I'm adding 0.5, I'm adding 6. If I'm minusing 0.5, I'm subtracting 6. So right here, this 6 minus 6 is going to give me 0. So when there's 0 amps, it's because we have 0 volts. And that's the starting point, which is going to be down here at 0, 0. Okay. Now it tells us to represent the data from the table onto the grid. So remember, going up and down, that's my Y. Going horizontally, that's my X. The X happens to be current, and the Y is volts. Okay, now what we need to do is look at what is the maximum readings that we have. Well, 48 and 4. And you can see none of our numbers, our lowest ones, do not go below 0. So that's why we don't have anything outside of quadrant number 1 right here. And so going up and down in the Y, I need to get to 48. So I need to count how many little lines there are. So there's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24 lines. So if I made each sort of 2-line jump right there worth 2, then that would get me to 48. So this would be 2. Nope, sorry. I'd have to double that. That'd be 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 42, and 44. Now, what about going in the Y direction, or sorry, the X direction, horizontally? We're getting to 4. Now, notice here there's these darker lines. Those are our major lines, and these are our minor lines right here. I have 1, 2, 3, 4, 5 major lines. So it sort of makes sense to use those ones and go, that is going to be 1, 2, 3, 4, and 5. So in this case, this would be 0.2, 0.4, 0.6, 0.8, and 1. 1.2, 1.4, 1.6, 1.8, and 2, and so on. So that's the first thing you need to do, is figure out the distribution of the numbers, what labels are going on the X and Y axis, and get everything labeled up. Okay, so now we want to plot those points. So let's look at the first one at 0.5. Now remember, we're going 0.2, 0.4, 0.6, so it's going to be in between right there. And when it's 0.5, it's at 6, which is that point right there. So I'm going to go grab a color right here and come over there and go to here. There's our first point right there. Now, really, if it's going to be a straight line, so it should go from the 0, 0 point and be going through that point right there. Now let's just see if that works out. Let's go to the next one that says at 1.5, it's at 18. So again, I'm going to go 1, 1.2, 1.4, 1.5, and where does it cross? Right around there. So my line's a little bit off, but we only had 2 points at that first when I was making my line. So 1.2, 1.4, 1.5, and 16, 18 should be right there. Okay, so I can delete this line, and let's see if we can make it a little bit. So it's going like that. Should be going through those 2 points-ish. Okay, and let's try the next one, 3 and 36. So 3 is easy. It's just 1, 2, 3, and if I come up all the way, that's where it's crossing. And if I look across, hey, I'm at 36. That's all good. No problems there. The next one is 3.5, which is right here. So essentially what I'm doing is I'm measuring up from the 3.5 up to that line and then going across from there over to this point. And you can see I end up at about, oops, I labeled my labels wrong. I just saw I went from spacing of 4, 4, 4, 4, 4, and for some reason I went from 40 to 42. That should be 40 to 44, and then 48. Okay, so that should be a 42, which it is right there. Lands right at that point right there. Okay, and the last one says when we're at 4, it should be that point right there. And if we go across, you can see that we end up at 48. So right across here, we end up at 48 when we're coming from 4. And everything falls on that line. Now it says, do we just want the dots, or do we want to have all the different points? Okay, well, I would say in this case that, you know, we would want to have a line, because you can have voltages of 6, 6.1, 6.2, 6.3, 6.358. We can have current ratings of 1.4, 1.5, 1.6, 1.8, 1.82, 1.83. So there's sort of infinite number of ranges on both of those. So yes, I can create a straight line. And by using that line, I can come up here, and without doing any math, I should be able to go, well, if I had a current of 2 amps, I should have a voltage supply of 24 volts. And actually part C is asking me to do that. So it's saying use the graph to determine the voltage for a current of 2.5. So again, what you're going to be doing is finding 2.5, which is about right here. We're going to draw a straight line until it hits right there. And then we're going to draw one coming across right here until it hits at that point. That is where it's at, and we can see that that value right there is going to be 30. So that would be 30 volts. Write an equation for this expressing V in terms of I. So again, normally we've got the form of Y equals mx plus B. Okay, and B is where it's starting off. Well, where did we start off? We started off at 0. So we're going to substitute that in with the 0, which is basically just going to cancel that. What is the Y? Well, again, right here, Y is the voltage, and X is our current, I. So Y is V. So I'm going to replace the Y with a V equals M is the, remember, that's going to be the change in Y over the change in X. So I need to go back here and find out, I got to find a spot where there was even sort of spacing, which is right here. So I can see for every 0.5, or sorry, if we're going with Y, it's going to be 6 over 0.5. So the change is 6 for every 0.5, which is the same as 12 over 1, which is the same as 12. So that number would be a 12. And instead of X, we're going to put an I for current. And it is plus 0, but I just wouldn't represent it that way. So it's just going to be V equals 12 times I. Okay, and now that we've got this formula, it's telling us to use the equation to determine what is the voltage if the current is 6.2. So basically, I'm just taking my formula, V equals 12I. It tells me that I've got a current of 6.2 amps, and I'm just going to substitute it in there. So V equals 12 times whatever goes in I, which is 6.2. And now I'm basically just going to multiply 12 times 6.2, and then we've got our answer. So really quickly, 12 times 6.2 it equals, we got 74.4. So the voltage of 74.4 volts would give us a current rating of 6.2 amps. Okay, and part F says the resistance ohms is calculated from the equation V equals I times R. So voltage equals current times resistance. State the resistance in this electrical circuit. Okay, so if we take our equation, which is voltage of 74.4 equals I, 6.2 amps, times R. Now I just want to divide this by 6.2, divide this by 6.2. So if I divide that by 6.2, I should get these canceling, and we're going to get R equals 12 ohms. Okay, now we're going to be looking at a couple terms. We got discrete and continuous variables. So you can see in our equation of the line, we've got a y value and an x value, and we have to figure out if these variables are discrete or continuous. So if we look at the top section right here, in class example number 3, it said that current and voltage are examples of continuous variables since they can take on any value. Okay, so even though we only took readings at specific points, there are basically infinite number of values that can be read or determined for each one of those variables. And it says in class example number 2, it looks like we were talking about discrete because they are not continuous. Okay, so when we take a look at the example down below, we're trying to figure out which ones are continuous and which ones are discrete. Okay, so what is the time to complete a 100-meter sprint? Well, people don't finish a 100-meter sprint at 10 different selected times. It could be really any infinite amount of times. So that would make this one continuous. What about the height of a student? Okay, well, the height of a student is also going to be continuous in the sense that you don't grow at 174 centimeters and then wake up and all of a sudden you just jump to 175. You grow infinite amount of measurements in between 174 and 175. So it's a continuous growth. The number of students who pass math. Well, again, this one would be discrete because I can't say that 7.2 students passed math. Either 7 or 8 of them are going to pass. That makes sense. The shoe size. Now, that's not the growth of feet or the size of feet. That would be different. That's like the size of a student. But if you're talking about shoe size in particular, when you go to the shoe store, you can't buy like size 42.187. It's going to be size 42, 43, 44, etc. So that is discrete. Okay, and we're at the end of this lesson, and we've got the assignment questions 1 through 12 on whatever page this happens to be, 392. And we won't have an in-class assignment because you have class tomorrow morning, and I haven't even posted this to the channel yet. So I will get on that right now, and we'll see you tomorrow.